Hi students, good evening to all of you. Today we are going to discuss about formal charge. Right, let's start. I am giving here a simple trick. General method you are following, a formula you have to apply, and then you have to know the Lewis dot structures, and then how many lone pairs and bond pairs are there, and you have to apply in that particular formula. Instead of that, I am giving one simple excellent trick. You just follow it. By seeing the question, you have to answer it. Yeah. Formal charge of carbon. For example, a carbon, take it here. If carbon having 4 bonds, 4 covalent bonds are there, right? All are bond pairs. Then formal charge is 0, right? Next one, it is 0. If the carbon having 1 bond pair is lost and it is present as a negative charge or lone pair, then it have -1 formal charge. The carbon having 3 bond pairs and this bond pairs of electrons lost and it gets positive charge, then it have formal charge of that carbon is +1. In case of nitrogen, for example, I will give some examples here to easily understand here. This is for carbon. How to calculate formal charge of carbon? So, for example, they will give, for example, methane, CH4. In this, formal charge of carbon 0. For example, CH3 minus. It is a methyl carbanium. Right. So here carbon, 3 hydrogens are bonded, 3 covalent bonds, and it have a negative charge. It is methyl carbanium. In this, the carbon formal charge is -1. Next, CH3 plus methyl carbocation. Here the carbon is bonded with 3 hydrogens and it lost one of the covalent bond. It lost this one of the covalent bond, right? This one. It lost its one of the covalent bond and it is present as here negative charge and it is present as here a positive charge. A positive charge. This bond pairs of electrons lost and it getting positive charge. So that's why the formal charge of carbon is +1. Right. Next one. For nitrogen, how to calculate formal charge without applying formula? Nitrogen, if it have 3 covalent bonds and 1 lone pair of electrons, then whose formal charge is 0, right? For example, we take ammonia, NH3. Then nitrogen is bonded with 3 hydrogen atoms and it have 1 lone pair of electrons over the nitrogen. So this is the lone pair of electrons are there. If nitrogen have 1 lone pair of electron, then the formal charge of nitrogen is 0, right? If it have, for example here, 2 bonds are there, 2 bonds, and then this bond pair is there, right? This bond pair, it is present as a lone pair, and this is normal lone pair, right? Now this is responsible for negative charge. This one is responsible for what? Negative charge. This one. So that this negative charge is present, that means two bond pairs and two lone pairs are there. One is as a negative charge. Then for that nitrogen, formal charge is -1. For example, NH2 minus, there nitrogen is bonded with two hydrogen atoms, and already one lone pair is there, and negative charge, this is the lone pair due to negative charge. So this NH2 minus, there nitrogen formal charge is -1. Got it? Next one. So in case of, if nitrogen have four bond pairs, four bonds are there, four covalent bonds, it is then the nitrogen having a formal charge is +1. For example, ammonium ion NH4 plus, we have to represent central atom nitrogen, and it have four covalent bonds, and this lone pair is there, right? This lone pair of electron, this one. This lone pair of electron is utilized in bond formation, this one. This lone pair of electron is utilized in bond formation as a coordinate bond. So for example here, this lone pair forms a coordinate bond with hydrogen. That's why the nitrogen utilizes its lone pair of electron to form a covalent bond with hydrogen. So that's why it loses its lone pair, right? It not exactly loses, it shares that lone pair to make a coordinate bond with the hydrogen. So that's why it utilizes that lone pair, it gets positive charge, right? Then nitrogen have a positive charge, formal charge is +1. Next one. In case of oxygen, for oxygen having a two bond pairs and two lone pairs. Two bond pairs and two lone pairs are there. Then the formal charge of oxygen is 0. For example, H2O, then oxygen have two bond pairs are there. Oxygen have two bond pairs and the two lone pairs are present, H2O, right? Next one. If oxygen having here to get negative charge, you have to make it here one bond pair is there, and these two, it is a lone pair, it is a negative charge. This bond is lost, and it is taking the two electrons from others, so it gets these two, and it is this bond break up, and hydrogen is removed as H plus. Then the two electrons are taken by this oxygen only, right? Now it gets negative charge, and this, as usual, these two lone pairs of electrons are present. Only one bond pair is present. Then in this case, the formal charge of oxygen is -1. That means we have totally 1, 2, 3. So three pairs of lone pairs of electrons are present here. Here two lone pairs are present. Here two bond pairs and two lone pairs. Then the formal charge of oxygen is 0. If one bond pair and three lone pairs are present, one bond pair and three lone pairs of electrons are present, then in that case the formal charge of oxygen is -1. Okay, right. Next, if the oxygen having here three bonds and only one lone pair is present, you would have only one lone pair is present. So three bonds and one lone pair is present. In that case, the formal charge of oxygen is +1. Here 1, 2, 3. So this is also lone pair, right? It is a negative charge. Here two lone pairs. If oxygen having two lone pairs, formal charge 0. Three lone pairs, formal charge is -1. One lone pair, formal charge is +1. Right? Next, in case of fluorine, for fluorine, there is not only for fluorine, chlorine or any halogen, right? So fluorine, any halogen X, take it, halogen. A halogen. If we have one bond and 3 lone pairs are present, then the formal charge is 0. For example, HF, then formal charge of fluorine is 0. It have 3 lone pairs and 1 bond pair. Okay, it is visible, right? Next one. In case of if fluorine have, here this is also present as, see, 1, 2 and 3 lone pairs are there, and this bond also is having a negative charge, right? Total 4 pairs are there, then the formal charge is -1 fluorine, right? It is like this, F minus. Okay, so this is this one, this formal charge, this is negative charge. Remember, these 3 are a normal bond pairs. Okay, got it. Next one, if fluorine have only 2 lone pairs are there, and the third pair, and it is getting a positive charge, that means it lost this bond. It lost this bond completely. Here it gains this bond and as a lone pair, negative charge, but it lost this bond pair. So that's why it get positive charge, +1 formal charge. Is it clear? Right. Now, this is the concept I give. Simple method. Carbon 4 bond pairs, formal charge of carbon 0. 3 bond pairs, 1 lone pair, -1. 3 bond pairs, positive charge, +1. Nitrogen, the 3 bond pairs, 1 lone pair. 1 lone pair is there on nitrogen. Neutral, there is formal charge 0. And here 2 lone pairs and 2 bond pairs are there. The formal charge of nitrogen is -1. 3 bond pairs, 1 lone pair, but that is present. That is not present as a lone pair. There is also participating in bond formation. So totally 4 bond pairs are there. 4 bond pairs. There is no lone pair. There is no lone pair. So here 1 lone pair is there. Formal charge of on the nitrogen 0. If 2 lone pairs are there, then the formal charge of nitrogen is -1. If 0 lone pair is there, lone pair are not there, then formal charge is +1. Got it. Oxygen, 2 lone pairs, 2 bond pairs, 0. 1 bond pair, 3 lone pairs are there, -1. 3 bond pairs, 1 lone pair is there, +1. Like that here also fluorine. Is it clear? We do some examples to get it. By keeping this concept in our mind, without applying formula, you can easily calculate the formal charge. By seeing the question how to answer it. See, for example, take it here. Ozone molecule. So ozone having 3 oxygen atoms are there. So it have, there is 1, 2, 3, 4, 5, 6 electrons. And then this oxygen also, there is 1, 2, 3, 4, 5, 6. This oxygen 1, 2, 3, 4, 5, 6. Right. So oxygen having how many valence electrons? 6 valence electrons. You have to represent like this. Okay. And here each oxygen having 6 valence electrons. So you can just number for our convenience is the first oxygen, with the second oxygen atom, this is the third oxygen atom. With the first and second oxygen atom, this first oxygen contribute 2 electrons, second oxygen also, first oxygen contribute 2, second oxygen contribute 2, and forms 2 bond pairs, 2 bonds. And the second oxygen donate this lone pair to the third oxygen, and both are share it. It forms a coordinate bond. Right. This is a donor atom, second oxygen. Third oxygen atom is just acceptor. Right. Now they will give this structure. What is the formal charge of first atom or second oxygen atom, third oxygen atom? They lost, or central oxygen atom they lost. Okay. We need to apply formula. Right. Look here. What I gave. If the oxygen having 2 lone pairs are there, formal charge is 0. 1 lone pair is there, formal charge is +1. 3 lone pairs are there, formal charge is -1 over. See, here this oxygen having 2 lone pairs, so first oxygen formal charge is 0. Here this one lone pair only there, so for second oxide atom forward charge is +1. Here three lone pairs are there, third oxide, so that's why third oxide having forward charge is -1. Over, right? Like that you have to do it. Next, one more example. If we take it here, the molecule is carbonate ion. Carbonate ion, CO3 2 minus. So carbon is bonded with 3 oxygen atoms, right? Carbon having how many valence electrons? 4 valence electrons, right? Okay. That is 1, 2, 3, 4. Okay. Then oxygen having 6 valence electrons. That is 1, 2, 3, 4, 5, 6. Okay. So carbon valence electrons how many? 4. 4 valence electrons. 1, 2, 3, 4. Right. Then this oxygen having how many valence electrons? 6. 1, 2, 3, 4, 5, 6. This oxygen also 1, 2, 3, 4, 5, 6. Right? Okay. Now, it is a CO3 2 minus. That means it gains 2 electrons, right? -2 means it gains 2 electrons. That electrons are represented that are belongs to now carbon, right? So this is 1 electron, this is another electron. Right? Then you have to represent this is CO3 2 minus. Okay. Now, what is the formal charge of oxygen, carbon and oxygen? All these oxides you have to represent. This is 1, this is second oxide, this is third oxide atom and carbons. Right? Okay. Now, first oxide. You have to represent the bonds here for our convenience. It is given the structure. So, oxide provide 2, carbon provide 2, double bond. And this carbon, it donates its lone pair and to the oxygen and share it, coordinate bond. And it is also with the third oxygen also a coordinate bond, right? Now, tell me oxygen here. So, 2 lone pairs are there. So, formal charge of oxygen is 0. Second oxygen, 3 lone pairs are there. 1, 2, 3. So, second oxygen atom formal charge is -1. And the third oxygen atom, 3 lone pairs are there. So, -1. Carbon it utilizes all the lone electrons, right? Carbon, no lone pair. No lone pair means it is a 0. Right? Over. Next one. One more example right here. Take it SO3 molecule. Sulphur trioxide molecule. SO3 molecule. Okay. Sulphur trioxide molecule. Sulphur trioxide molecule. Sulphur trioxide molecule. Right. Here sulphur central atom and 2 oxygen atoms are there here. We will represent here. SO3, sulphur trioxide. Sulphur central atom and here 2 oxygen atoms are there. And it provides, so sulphur trioxide, 3 oxygen atoms, right? 3 oxygen atoms. And here, sulphur having how many valence electrons? 6 valence electrons. There is 1, 2, 3, 4, 5, 6. Oxygen having, each oxygen having also 6 valence electrons, right? You have to represent that one also, oxygen. 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, right. Now this sulphur provide 2, oxygen provide 2 and forms a double bond. This sulphur it forms a coordinate bond. This sulphur forms coordinate bond. Now, what is the formal charge of oxygen here? So 1, 2 and 3. Here, first oxygen atom. Here, 3 lone pairs are there, formal charge is -1. Second oxygen also 3 lone pairs are there, formal charge is -1. Third oxygen atom, second oxygen 2 lone pairs are there, formal charge is 0. What about sulphur? No lone pair, 0. That's it. Is it clear concept, my dear students? Right. Okay. I think you enjoyed. So thanks for watching my video. Like it, subscribe it and share to your friends. Fine.